Vijay Chandra Jadala welcomes you to VC Tech Education. Today we are going to discuss regarding the modules in Python. We are going to discuss in detail regarding importing module, math module, random module and packages. A module is a file consisting of Python code. A module can define functions, classes, and variables. A module can also include runnable code. Grouping related code into a module makes the code easier to understand and use. Any Python source code can be used as a module by executing an import statement in some other Python source file. That means we can import the module in another Python source file. That means one Python file will be created which used as a module, and this module can be included in another Python file. Import has the following syntax: import module 1, comma, module 2 up to module n. When the interpreter encounters any import statement, it imports the module if the module is present in the search path. So in particular search path, this module should be there. The search path is a list of directories that the interpreter searches before importing a module. So once again, regarding the module, a module is a file that consisting of the Python code, and where this particular source file is used as a module and we can execute it in another Python file. Import module name. Example we taken hello.py is the program def greet str, where str we are printing hello as str. That means in str the hello will be stored, that is of greet. Now we will import hello.hello, that is we are importing the module hello.py. Then hello greet Python, then the output will be hello Python. So from the import statement, Python from statements let you import the specific attributes from a module into the current namespace. The form import has the following syntax: from the mod name, import name1, name2, name3 up to name n. So cal.py, def add of x comma y, return x plus y, def sub of x comma y, where it will return x minus y, def mul x comma y, return x into y, def div x comma y, where it will return x by y. So here we are defining all these things in cal.py. Now we are going to use another program known as text.py. From cal import add sub. Only two terms we are going to import, that are the add and sub. So print add 10 comma 20, print sub 10 comma 20. So the output will be 10 plus 20 for the add, that is 30. Next is sub 10 comma 20 means 10 minus 20, that is minus 10. From import star statement, it is also possible to import all names from the module into the current namespace by using the following import statement: from mod name import star. This provides an easy way to import all the items from a module into the current namespace. Test.py, from cal import star, print add 10 comma 20, print sub 10 comma 20, print mul 10 comma 20, print div 10 comma 20. So the output will be 10 20, that is adding, that will get 30. 10 comma 20 subtraction minus 10, 10 into 20, that is 200, 10 divided by 20 is 0.5. So all this will be done by using the import statement where we are importing from the another program of Python. Using alias name. If possible, to modify the names of the modules and their functions within the Python using the as keyword. So, as is the keyword which we are going to use for the alias name. Import module as another name, that is nothing but the alias name. You want to change a name because you all already use the same name for some other else in your program. Another module you have to import and also the name is the problem. So you can use it for the abbreviate from a long name to a short and you can say it as an alias name. So the syntax is import module as another underscore name. Test.py, we are going to import calc as C, then output print c dot add of 10 comma 20, then that is equal to 30, print c dot sub of 10 comma 20, that is minus 10, print c dot mul of 10 comma 20, that is 200, since c dot div of 10 comma 20, that is 10 by 20 equal to 0.5. So this is all about the importing and using an alias name. Then comes to the dir. The dir built-in function returns a stored list of strings containing names defined by a module. The list contains the names of all modules, variables and functions that are defined in a module. Example, import calc, print dir of calc, then we given in a square bracket all other things that are variables, functions and other things. Then comes to the random module. The random module provides access to the function that supports many operations. The most important thing is that allows you to generate a random numbers. Random functions randint that generates a random integer. Randint accepts two parameters, a lowest and a highest number. Import random that generates a number between 2 to 5. Random randint of in braces 1 comma 5. Choose generates a random value from the sequence. Example, random dot choice in single quotes red comma black comma green. So randomly one will be picked up and display and it will be displayed. Next come to the shuffle. Shuffle function elements or the elements in the list places will be changed. That means the shuffle function uses the elements order will be changed. Shuffles the elements in the list in place so they are in a random order. Example, I equal to small I for I in range of 10. So the values will be 0 to 9. If we use shuffle, the values will change its order. Next, random range. Generally, the random element selection of the element is having a range, that is start, stop and step. That means after how many steps? That means if I give start 1, stop 4, step 1 means it will go 1 plus 1, 2 plus 1, 3, 3 plus 1, 4. So 1 to 4. So if I give step 2, 1 plus 2, 3 and step 4 is the final. So once again if I use plus 2, it will overcome the end point. So 1 and 3 will be the output. If I use step equal to 2. Then syntax random dot random range rand range start comma stop on comma step. For I in range of 3, print random dot rand range 0 comma 100 comma 5. Next comes to the modules related to the math. The math module is the standard modules in Python and is always available to use the mathematical functions under this module. You can have to import the modules using import math function in math module function and description CEIL of x returns the smallest integer greater than or equal to x. Copy sign x comma y returns x with the sign of y. FABS of x absolute f absolute x returns the absolute value of x. Factorial of x returns the factorial of x. Floor of x returns the largest integer less than or equal to x. F mode of x comma y returns the remainder when x is divided by y. FRX exp of x returns the mantissa and exponent of x as the pair m comma e. F sub of iterable returns an accurate floating point such floating point sum of values in the iterable in is finite of x returns true if x is neither an infinity or nor a nan not a number. So these all are the mathematical functions just we can do at the time of the practical sessions. Then is INF returns true if x value x is a positive or negative infinity. Is nan of x returns true if x is a nan. Mod f of x returns the factorial and integer part of x. Trunc of x returns the truncated integer of x. Exp of x returns exponential of x. Log 10x returns the base 10 logarithm of x. POW x comma y returns x raised to the power of y. And SQRT of x returns square root of x. A cross x returns arc cosine of x. A sin x returns arc sine of x. A tan x returns arc tangent of x. Pi pi mathematical constant the ratio of circumference of a circle to its diameter 3.1459. Mathematical constant E 2.781828. So this is all about the different functions. After the function, different import related modules, functions in the math modules. After this, next topic is the packages. A package is a collection of Python modules. That is, package is a directory of Python modules containing an additional init.py file. Each package in Python is a directory which must contain a specific file called init.py. This file can be empty and it includes the directory it contains in a Python package. So it can be imported the same way a module can be imported. When you import a package, only variables or functions or classes in the input init.py file of the package are directly visible, not sub-packages or modules. Steps to create Python package. Create a directory and give it your package name. Put your classes in it. Create a underscore init underscore .py file in the directory. So that underscore init underscore .py file is necessary because with this file Python will know that this directory is a Python package directory other than an ordinary directory. So this is all about the packages. By this I conclude my session related to the topics of importing modules, that is importing modules, math module and random modules as well as packages. So here hope you understood well. When you do the practical sessions regarding module, you will have a better knowledge in Python. By this, I am concluding my lecture. Hope you all understood well. Thank you.